Okay, so let's start with examples for chapter 5 then. The first example here is that of basically account balance. Again, we want to check the account balance, and this program calculates a customer's checking account balance at the end of the month. So again, we have got some initial declarations. Notice the header file F stream here, which is going to be included for file stream, IF stream and output stream, I think. And in this case, the minimum balance is basically 1,000 rupees. That's a constant value. You don't want to go below that. The service charge is 25. It's also a constant double value. And I think we need to wait a minute. Yeah, so then we declare and initialize some variables. That's all that we're doing here. A couple of them with some values, etc. Then you've got an input stream and output stream initialized. You open the input stream. If the input stream is not found, you simply output that cannot open the input file, cannot find it, and the program will terminate right away. Otherwise, open the output file stream, fix it. So why we do not check for the output file stream is that even if it's not there, we'll just make it out. So it's not an issue. We're opening it for writing it out. However, the input file stream has to be present already. If it's not present, we need to give an error and move on. The output file is then, you set the manipulators. You then see out the processing data. And from the input file, you read two numbers, put them in. You start with the account balance. And then from input file, you read the transaction code as well as the transaction amount. So while in file is true, so this is something that is an example of a end of file controlled system. So until an end of file is not found, you actually switch between transactions code. And based on transaction code, you actually update your account balance, your amount deposited, and the number of deposits, etc. Or you can use the account balance and interest paid, or you can basically use the account, update the account balance or amount withdrawn, and as well as the number of withdrawals. And if the balance falls for the withdrawal, it falls below a certain range, well, this service charge is going to be becoming true. And finally, you basically have the default value. If it's neither W nor I nor D, in that case, you're going to have an invalid transaction code. So this is something that uses switch statement. As you can see here, it uses the break statement in the switches at the correct places. It uses the file reading and writing concept that was taught in the previous lectures, lecture 3, chapter 3, and so on. So finally, it then outputs into the out file. It writes into the out file all of these things. And if a service charge, then you also write that. And finally, you return 0, you end the program. So what we learned in this particular program is how to use all the main purpose. The new thing that we learned in this program is how to use a end of file inside the while loop to calculate or perform a certain task. And in this case, if you open the file, what's the file name here? So the file name that is going to use change 5 underscore money.txt. So underscore money.txt, where is the file? You must have it over here, change 5 money.txt, which is this file. And we notice that it contains these different values, transactions. All of these are transactions, and these are supposed to be read each time. And when we read them, we observe that. So let's just, yeah, so I'd like to close it out and actually execute the program that we were just seeing. So I want to execute this program now and maybe delete the file money.out. I want to delete it from the system so that it's not present. Right, and now I can execute this code, and this is going to be reading from the file all the transactions that were made, and based on those transactions, it is going to tell me the balance, processing data, it's done. And now we have got a change file money.output file that is made. In this case, it knows that account number is this one, beginning balance is this much, and ending balance is this much, interest paid is this much, amount deposited is this much, number of deposited is this much, amount withdrawn is this much, and number of withdrawals are this much. So this runs the program and reads from the files, does all the computation, and writes out the result. Notice that this while is going to run until everything in the file we reach at the end of the input file stream. So this is an EOF controlled while loop, an example of that. Let's move on to the next example, which is the average calculations with a loop. And here you have got calculations burned in a day, calculations burned in a week, number of days. For example, on day one, for example, you burn certain number of calories. So while you do not reach the day 7, you want to calculate it for 7 days. You want to basically output the calories burned by the day, calories burned in a day, you taken from the user, and then calories burned in a week is calculated by using this particular formula. And finally, you increment the day as well. And finally, the average can be calculated by simply dividing the calories burned in a week divided by 7 to get the average number of calories. And I'm not going to run it now, but this is a typical example of where you're going to execute it using a counter control. So day is a counter which is being incremented continuously, and until it reaches 7, you'll continue to run it. Personally, or the recommended way here would be to use a for loop, but this is an example. Since it's an example of while loop using a counter controlled, hence this runs fine. Of course, for can be converted to while loop exactly as you might see in the next few examples. So here is how you're going to execute it without using loops. And if you don't use loops, here's how many times you have to write the same code again and again and again, and how many different variables you have to declare for the same purpose. And the previous program actually helps us perform exactly the same function in a much more concise and much more readable manner. And I think that makes more sense to any reader as well. And once you practice and once you become an expert in using loops, I think you can never ever code like this for anything that can be done in loops, even for a two variable thing. You always prefer to use a loop. Okay, so the next example here is a program that counts zeros, odds, and evens. This program counts the number of odd and even numbers. The program also counts the number of zeros, right? So let's start with the int n is equal to 20, and is a constant number here. We want to change it. You start the counter. There's here some declaration of variables. You start the numbers. You start zeros, odds, and evens by 0. So since nothing is observed, all of these start with 0. Then you ask the user to enter n integers, positive, negative, or zeros. He enters n integers. How does he enter n integers? Well, for counter is equal to 1, counter is less than equal to n, counter plus plus, right? So this is now using a for loop where you start from 1, go till n, and increment the counter throughout. You ask the user for a number, you output the number, you move on to the next one. In case the number is you divide it by 2 and get the remainder. If the remainder is 0, we say that the number is even, so even is incremented. If the number is 0, then zeros is also incremented, right? And finally you break. If the number is 1 or minus 1, in either way, you basically increment the odd and basically end the switch statement. Finally, an end for loop, and then you basically say the number of output, the number of even and odd, etc., the number of zeros encountered. So in this case, you see we use a for loop for counting them, but here's the intelligent part: we're using a switch loop, a switch statement within the for loop, and this is an interesting use of it. Like I said, you can use the switch statement also to get the instead of a if else condition, and instead of the if else condition here we're using the switch statement. So now moving on to the next example quickly. This program computes and outputs the total number of boxes of cookies sold and the total revenue and the average number of boxes sold by each volunteer. So again, some initialization, some fixing in the some manipulation in the manipulators. Then you output the number of, you get the number of volunteers. You want to get the total number of boxes sold and counter. So while counter, so this is a counter controlled while loop. And while this counter is less than number of volunteers, you'll continue to ask for certain things, and you're going to count the total number of boxes sold, and the counter is going to be incremented. And with that, we make some further calculations, use the if else loop to find out the values and return the result. So the main take home, the new thing that we learned from this particular point is how a while loop can be controlled using a counter. and a counter controlled while loop is the main learning objective of this example. So moving on to the next example, divisibility test by 3 and 9. Well, what we know is that we need to extract each digit. So let's just talk of the algorithm. How is a number divisible by 3, or how is a number divisible by 9? The simple way is you sum them, or sum all the digits up. So for example, 27 is divisible by 3. Well, 2 plus 7 is 9. 9 is divisible by 3. So yes, it is divisible by 3. Is the 26 divisible by 3? No, because 2 plus 6 is 8, and 8 is not divisible by 3. So 26 is also not divisible by 3. Sorry. Okay. And let's say if you talk about 81. 81 is divisible by 3 because 8 plus 1 is 9, and 9 is divisible by 3. Again, this word divisible is very hard for me to pronounce in a flow at times. So really sorry for that. Okay. So is 1101 is it divisible by 3? Yes, it is, because 1 plus 1 plus 0 plus 1 is 3, and 3 is divisible by 3. So 1101 is also divisible by 3. The same goes for 9 as well, but the only difference is that the sum of the digits should be divisible by 9. Hence, 81 is divisible by 9, 84 is divisible by 3, but not by 9, and so on. So the program is based on that logic. It first extracts the each digit, adds it to the sum, and continues this process until it computes the sum of all the digits. And based on the sum, if the remainder of sum after dividing it by 9 is 0, the number is divisible by 9 and by 3. Otherwise, if it is only divisible by 3 alone, then it is divisible by 3 and not by 9. Otherwise, it is neither divisible by 3 nor by 9, and then it stops. So that's the whole program in a nutshell. But the learning point here is it uses a do while loop. So it computes, it has to run it at least once. So sum is whatever the number. If it's a single digit number, you just convert it into, you just extract that single digit, add it to the sum, and this becomes sum. And finally, the number is then divided by 10 to just get the. So this is an integer number as it will be returned, and this number now has the last digit removed from it, so that the next digit can be extracted in the next loop, in the next iteration, and so on. So in each iteration, it extracts one number, the last digit, and then it adds it to the sum, and then it removes the last digit and moves on. And the rest is kind of very simple. But this is, slightly tricky code, but this gets you the results for if a number is divisible by 3 or by 9. So another example, let's move on to the next one, is a program that reads data from a file consisting of students' names and their test scores. The program outputs each student's name followed by the test score followed by the grade. The program also outputs the average test score for all the students. And this is an example which is controlled by, again, you're reading through the files here, you're declaring some variables, you are going to open the file, you're going to check for the input file if it exists or not, open the output file for writing out stuff. And while you do not reach the end of the file in the input file, you perform all of these things, calculate the grade, do everything else that we did for a single student earlier on, but now we're going to do it in a loop, and this means it will be running until the end of the file is reached. And once you reach that, you basically output these, write the output and whatever is needed. For example, the average needs to be output to the class average. And finally, if you don't have anything and not a single value, then you simply output no data and close everything and return. Again, I'm not going to run it for now, but this is absolutely clear that what we need to learn in this particular case is how to use end of file as your condition operator within the while loop. So then we have got the Fibonacci program that you saw in the class earlier, and this is again the same program. We just run it, and in this case we see the usage of a while loop inside the else here, and that was the algorithm that you made up and you came up with, and this was the exact piece of code that we found earlier on, right? So this is really nice. The other alternate to calculate Fibonacci number is by using a for loop again instead of a while loop. And here it's the same code, same thing. The only difference is using a for loop here. And this is easier to understand because you have to run it until nth Fibonacci, and this becomes really nice. So this is a for loop example for Fibonacci sequences. Moving on to the next example, which is a flag controlled while loop and the number guessing game that we also saw in the main lecture early on. In this case, we want to guess the number, and until we don't, either we don't guess it or we have, ran X number of times, we are going to, keep on trying to guess. Notice that we have included a library which is called ctime, right? And we have also included a library which is Cstdlib. I told you in the lecture that Cstdlib is needed if you want to generate random numbers or use the rand function, which is, I think, given somewhere below. No. Yeah, srand is given and rand is given here. So this function generates a number. And srand time 0 is something you need to initialize the seed for the random number so that each time a random number is generated on a fixed pattern. So whenever you take the time of the current time of the system, to take this time 0, you need to include the ctime function. Once you have the ctime function included, you can actually use the srand time function along with the rand function to generate a random number. You can check it out by uncommenting. You'll always generate the same random number. By commenting it, by putting in this srand and then time 0 inside it, this generates the current time of the system, and the seed for the random number is basically a random seed all the time, because every time you run it, the time is different, so the random seed is different. And since the random seed is different, a random number will be generated in a different pattern. If the seed is the same random number will be generated throughout. So you can maybe put 100 here or 200 or whatever. In that case, the same random number will be generated throughout. And by the same, actually, I mean the same pattern, not the same number, but the same pattern. And each time within the loop, you need to make a guess. And if that number matches or not, you check it times, a certain number of times. And once that is exceeded, you're going to, stop the while loop. So until this guess is basically false, is guessed as false, this remains true. As soon as is guessed becomes true, for example, the guess is correct, or you run out the number of the guesses, then this becomes true again, and you actually quit the number. So each time, sorry, this is slightly different again. In this case, you're basically saying whether the guess is less than or greater than the your guess. If it becomes exactly equal, basically break using the flag here. The flag here is guessed. Otherwise, you continue to check you continue to tell the user that that your guess is higher or lower, and you need to continue to run the loop. And that's what the while loop does. The while loop will keep on running until either until the is guessed becomes true through this particular case. However, notice one more thing. You need to understand how to use these commands throughout. These are very important commands, in particular for projects. You'll be using them a lot, so you need to understand how these are running. You need to include these header files if you want to include these commands. So let's talk about loop with bugs, some certain issues here. So you open a file with this one. You put I is equal to 1. I is less than equal to 4, I plus plus, perfectly fine. J is equal to 1, J is less than equal to 4. Inside you take and read number from the in file. You basically see out the number, you perform sum and so on. Finally, the sum is computed. The issue here is that it might be that the sum becomes 0 at every step, right? And because sum becomes 0 at every step, you're basically inside the file, you're reading a number. So this in file is going to be executed 4 times for this one for loop, and basically 4 times for this for loop. So this in file is going to be executed in total 4 multiplied by 4, which is 16 times in total, because that is the example of a nested for loop, and this is what happens. So in total it's going to be run 16 times, although you might be wanting to run it for 12 times or 9 times actually, but because of the copy pasting thing here and you just change the name of the variable, this might become problematic. And this is the exact program. Like I said, you want to run it just 3 times and 4 times and in total 12 times. So this is exactly the correct code now. And we can see the file here. This is 3 times and not 4 times. So but just by having a wrong initialization here, which was 4 and 4, this less than should be either less than equal to should either be less than, or this should be 3 instead of 4, like it is done for the next example. It has been changed to 3. So for checking for loop with uh, bugs, and then you include a patch here. The patch here is simply that if I is not equal to 4, then we execute this. Otherwise, we for example, it's the same code, but you have added a patch here, a small patch, which just checks that if I is less than equal to if I is not equal to 4, then you should execute it. This should be avoided because this might introduce some unintended consequences here. And it runs fine for now, but if you change, for example, I to 5 later on, you want to include 4 or something, this piece of code is going to cause you a lot of problems, and you should actually fix it in the correct manner. Let's talk about another file, which is basically the sentinel control loop, an example of sentinel control while loop, I think. And yeah, and in this case, this program computes and outputs the total number of boxes of cookies sold, the total revenue, and the average number of boxes sold by each volunteer. And in this case, it's controlled by a sentinel. The sentinel value is exactly equal to -1. So whenever you enter -1, the program is going to quit, and that's what you tell the user as well. Enter each volunteer's name and the number of boxes sold by each volunteer, ending with -1. So whenever you end in -1, this is going to stop. Now then you ask the user for the name. So while the name is not equal to sentinel, so whenever the name is -1, it's going to ask you to enter the number of boxes sold. Total number of boxes sold, it calculates that. Then it increments the number of volunteers, and finally asks for the name again. If the name is not equal to sentinel, it will continue to run this code. When it becomes equal to -1, it's going to quit and compute the rest of the thing exactly as we did in the earlier example, right? So let's go on to the sum n numbers. This is a program to determine the sum of the first n positive numbers. So whatever the first positive numbers, we can do that. And this is a typical example for a for loop. How this works is basically you initialize some variables, you output, you get the number n. Since you know the number n, you just need to use it in the for loop, initialize it with 1. This is the check condition, loop control variable. As you can see, the name here is loop control variable, loop control variable, loop control variable for all of these. And this is exactly the thing as we mentioned earlier in the program. And yeah, so finally you execute the loop n times exactly and get the sum of the numbers. And then the program basically ends simply. Yeah, the loop ends and the program returns. This is the one for the telephone digits, the example that we discussed in the lecture. It is an example of a sentinel control loop again, which converts uppercase letters to their corresponding telephone digits. So while letter is not equal to hash, so until you don't enter the character hash, you're going to execute this program, and we can see what it does. So these are some nested if conditions here, and they'll keep on running. Invalid option, otherwise it asks you to enter another uppercase letter to find its corresponding telephone digit. And for each of the uppercase letter, it basically converts them to its corresponding telephone digit and moves on. And finally, it asks the user to enter a letter each time. If the letter is hash, it's going to quit. Otherwise, it's going to convert it into a corresponding uppercase digit. So the next example here is about the while loop and continue statement. So here what we observe is that this is a loop on the end of file on cin, and until you don't as soon as you enter a number, it continues. If the number is less than 0, it asks you to that it says that negative number is found in data, input the number again, and directly go there. Do not perform the sum, do not perform these steps at all. Since a negative number is not allowed in this particular program, you can skip negative numbers by simply introducing this piece of code, which says that if a negative number is found, output that a negative number is found, input the number again, and continue on. And with this, these conditions will never be executed if this if runs. If this if does not run, it's a positive number or number equal to 0, then we include this number in sum and again ask for input and continue on using the sum. Let's talk about another example, which is a statement that uses a break instead. In this case, what we do is whenever a first negative number is found, we want to actually break the while loop and move on. And this is what it exactly does. Whenever the first negative number is found, we actually break the while loop, goes on to the sum and return. So this will not continue to execute. In the previous case where we used a continue statement, the loop will continue on to run until basically you found the input to be a false value, right? That's the difference between break and continue. That's the main point of both of these examples. And finally, you have got a loop statement without break. So this is like uh, a statement. It does not contain a break statement, but instead it uses the is negative as a flag, as well as the cin, the sentinel control. So this is a multiple, or this also contains multiple and complex conditions as input for the while, and then it uses the if else inside it for a particular purpose, right? So I think that's about it for this lecture. In the next chapter, we'll then start with the other values and other things. We'll probably go for, I think the next topic that is coming up is going to be arrays. But we'll see arrays of functions or pointers. We'll see what the next topic is going to be. But it's going to be the next chapter, and we'll talk about this in a couple of in the next lecture, actually. So thanks for listening, and I hope you learned something during this lecture. Thank you very much.